Hi folks, sorry for the issues. Hopefully we'll get them cleared up. So the problem that we have the heights of women in college follow a normal distribution with a mean of 65 inches and a standard deviation of 2.5 inches. So notice that means first off mu equals 65 inches and sigma equals 2.5 inches. So if we want to determine the probability that a group of 35 college women have an average height of less than 5 feet 2 inches, we got to convert that to inches rather than feet and inches. So we get 62 inches. Okay? So when we take a look at this, if you had 65 sitting right here, and then we have 62 going right there, we're shading in that area. And then, as I said before, I like z-scores personally. So if I take 62 minus 65 and divide by 2.5, what do we get? I think that's what, negative 1.2. And so where we left off right before, and these problems, the issues tend to happen when I use the calculator more often, is when things shut down. So let's get this back rock and rolling. We have norm CDF, and then we want to punch in our negative infinity is where we want to go to. Whoops, don't want that value. So I can put negative 10 to the 6, or if you aren't sure to try and see, I just put 1 with a whole bunch of zeros, and then we go all the way to negative 1.2, and then we can close that off. And then we hit enter, and notice it should be less than a half because we're on that other side. And by the way, if we want a greater than 62, we can actually just go 1 minus this answer and get that side as well. So notice we get 0.115 as our final answer. So we have less than 62 inches, or less than, oh, wanted strictly less than or equal to, or less than, it's going to be the same answer. And I believe it was 0.115, correct? We'll see in a second here. So now, what do we want to do in this next case? What height will correspond to the tallest 5% of college women? So in this case, what we're looking for is we're looking for a z-score. We have that this is 5%. What that means, though, and our calculator is kind of dumb in terms of it can't usually go to both sides. It can only go to one side or the other in terms of its calculation. The 84s have a little bit more capability, but for this it's going to be 0.95 sitting out over there. So the reason why we can get away with saying that, we know the whole area underneath this curve is 100%. So if this is 5% or 0.05, that means the other side has to be 95% or 0.95. So when we go to this calculator, now what do we do? How do we figure out what's called a z-score? Okay, and for a z-score you can make it 0 and 1. I think some of the higher level calculators you can actually do computations where you can punch in the mean and standard deviation. It can give you the exact value. But for this, I'll give you the z-score. And how do you do that? Well, we want to basically take what's called an inverse. So this is what inverse norm is standing